So we're going to the second section for the oral presenter is Miss Wipa Huam Ho or is deliver for his presenter, Miss Wipa or Mr. Wipa. Miss Miss Wipa Huam Ho from Naresuan University. Okay, so we maybe have a lost contact with her. So I would like to invite Miss Nur Hidayatul Alami from Institute Technology 10 November to deliver his presenter with title Indole 3 acetic acid and antifungal production by yeast isolated from zophoric soil. Miss Nur
Yes, thank
Hidayatul
you.
Alami.
Yes, yes. But I have sent the recording to the committee. Maybe you can play the recording. Yeah.
Okay, so is okay. I would like to play the recording for you.
Assalamualaikum warahmatullahi wabarakatuh. And good morning, ladies and gentlemen. Thank you so much for the time given to us. I'm Nur Hidayatul Alami from the Biology Department, Institut Teknologi 10 November. And today, we would like to present our paper with the title Indole 3 acetic acid, IAA, and antifungal production by yeast isolate from rhizospheric soil. And this is the outline. And we go first to the background. So this is the background of this research. Until the last few decades, there are still many of the agricultural activities that use chemical fertilizers to enhance crop productivity. As we know that chemical fertilizer give negative impact on the environment. Several impact for the environment like loss of soil fertility, and then decreasing the quality of aquatic ecosystem, and then changes in the composition and biodiversity of soil biota. This happens because of the continuous use of chemical fertilizers. And several previous studies have revealed that potential of microorganisms as a biofertilizer agent, but only few have researched about yeast. Even though as a part of microorganism, yeast also can have a good potential as a biofertilizer agent. Yeast can be a prospective biofertilizer agent, and based of several reports that yeast have the important role in a soil, like stimulates the decomposition and mineralization of organic compounds, and then potential in producing IAA phytohormones, and can produce antifungal compounds that play a role against plant pathogenic microorganisms. So based on the background, the problem of this study are to yeast isolate from agricultural soil rhizosphere have the ability to produce IAA and antifungal, and the second, which yeast genus is able to produce the highest concentration of IAA and antifungal compound. And this is the scope of a problem. First, soil samples were taken from the rhizosphere of agricultural land in 3 different locations, namely urban farming, campus forest, and rice fields. And the second, these isolates will be tested for IAA potential qualitatively and quantitatively using UV spectrophotometer and the addition of 100 ppm tryptophan compound. And the third, yeast isolates that have been isolated will also be tested for an antifungal potential based on analysis of antagonistic activity against plant pathogenic molds using percentage growth inhibition values. And the fourth, the plant pathogenic fungi used in the study were Aspergillus niger, Fusarium, and Botryodiplodia. And the last is isolates that have the highest potential to produce IAA and antifungal will be identified to the genus level based on physiological tests, microscopic and macroscopic characteristics. And this is the methodology. The research began with the isolation of yeast from agricultural soil reservoir, and then we can do the purification. And after we got the pure culture, then we continue to the next step is characterization of yeast obtained macroscopically and microscopically. And after that, the step is continue to the qualitative test of yeast in producing the IAA hormone. And also the next step is yeast quantitative test in producing the IAA hormone. During this step, we also measure the yeast density using a spectrophotometer. In parallel, we can do the test for antifungal potential against plant pathogenic molds. And after we got the potential of the highest potential of the yeast, then we can continue it to the identification up to genus level by performing several physiological tests like urease test, sugar fermentation test, ascospores test, tests on liquid medium. And this is the results of the study. So the table shows the macroscopic characterization of yeast from rhizosphere. Based on the table, we can see here that there are various kind of the colony morphology in terms of shape, texture, color, surface, elevation, edge, and size. And this is the microscopic characterization of yeast. Based on the table, we also can see here that there are various colony morphology of yeast in terms of shape, budding, hypha or pseudo-hypha, and then cell size. And this is the result of the qualitative IAA potential test. And based on the result, we can see here that almost all of the isolates can produce the IAA. It's proof from the color change of yeast colony to reddish and this indicates the potential for yeast isolates to produce IAA. And before we continue it to the quantitative test, the first thing that we have to do is making the standard curve. And determination of the standard curve was used to calculate the concentration of IAA produced by yeast isolates. And the standard curve produced the equation of the line. Okay, and the next is the result of IAA quantitative test. The results show that each yeast has a different ability to produce IAA. And this is influenced by the physiological properties of each yeast in converting tryptophan to IAA. And from the result also, we can see here that the yeast isolates capable of the producing IAA with the highest concentration were SS3 of 47.5 ppm on the 5th day and SS4 of 45.86 ppm on the 7th day. And this is the result of IAA quantitative test. If we compare with the yeast cell density, and based on the result, we can see here that isolate of UF2, UF3, and UF7, the number of yeast cell was directly correlated to the concentration of IAA. We can see here UF2 and then UF3 and then UF7. However, the results also show that the concentration of IAA produced by isolates of UF8, SS4, HK4, HK12, HK1, SS3, and UF1 are also directly correlated to the number of cells. Are not directly correlated to the number of cells. And how about the percentage inhibitions of pathogen modes growth by yeast? From the results, maybe we can focus on the figure. The result on the antagonist test of yeast isolates, we can see here, and plant pathogenic modes using the dual culture method show that some yeast had the ability to inhibit the growth of moths. We can see at the bottom side of the figure. And this could be seen from the diameter of the mold mycelium, which was smaller compared to the control mycelium. And based on the results, we can know that each yeast isolate had the ability to inhibit specific pathogenic moths. This could be seen from the difference in the percentage of inhibition of the mycelium growth of pathogenic moths. And after we got the highest potential of yeast, then we can continue it to the identification step up to the genus level. And we have the isolate of SS3 and then isolate of HK1 here. And based on this character, isolate SS3 is estimated to be from the genus Pichia. And then for the isolate HK1 was estimated to be from the genus Candida. And the last is the conclusion. The first is most of the yeast isolates from agricultural soil rhizosphere have the potential to produce IAA and antifungal. These isolates that have the highest ability to produce IAA are SS3 isolates of 47.5 ppm. Meanwhile, the highest antifungal ability came from these isolates HK1. And the second, based on its microscopic, and physiological characteristics, isolates SS3 was estimated to be from the genus Pichia, while isolate HK1 was estimated to be from the genus Candida. Based on the research, we can give the recommendation. First, further research is needed on the application of these isolates that have the potential to produce IAA and antifungal as biofertilizer agents in agricultural crops. And the second, it's necessary to carry out a molecular identification test of yeast. And the last, it's necessary to carry out further tests related to the analysis of the types of antifungal compounds produced by yeast isolates with the highest potential. And so that's all of our presentation for today. If there are any questions related to our research, please give questions to us. Thank you so much. Wassalam.
Okay, thank you very much for your presentation, Ms. Nur Hidayatul Alami. So I would like to invite again Ms. Wipa of Naris One University. Let's see. person in this room. Okay, I think I should next to invite the next presenter is Miss Anna Mariatul Kiftia from Universitas Erlangga with the title Exploration of Plant Growth Promoting Bacteria from the Elephantonus caber L with your presentation. 10 minutes for your presentation. Miss Anna Mariatul Kiftia, time is yours. Miss Anna Mariatul, I didn't hear
Yeah.
your voice.
Okay. Do you hear my voice?
Okay, go
Hello.
ahead. Yes, I
Oh,
clearly hear
okay.
your voice.
Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Today, before I start my presentation, I would like to ask all of you, do you know about these plants? Yes, this plant is called Elephantotus caber in scientific name, and usually we call this plant as tapak liman in Java. Actually, this plant is well known as medicinal plant, but today I would like to present about exploration of plant growth promoting bacteria from the roots of Elephantotus caber. The background of this research is, first, Elephantotus caber have a potency in agricultural fields, although this plant is also well known in its medicinal fields. Its potency in agricultural fields such as biopesticide and inhibit phytogenic fungi due to its secondary metabolites. Besides that, Elephantosus caber is also known to have symbiosis with microbes. Endophytic bacteria, which is live in the plant tissue that isolated from plants, shows antimicrobial activities just like as its host. So, endophytic bacteria have so many potency. Besides inhibit phytogenic fungi, endophytic bacteria is also well known to have other potencies such as enhance plant growth, uh, enhance plant growth, such as provide plants with phosphate or fixing nitrogen. So the aims of this research is to explore plant growth promoting bacteria from Elephantosus caber. The methods of this research is first, surface sterilization. So the roots of Elephantosus caber was surface sterilized, and then isolation and characterization, isolation of bacteria from the roots of Elephantosus caber, and then the bacteria that was obtained were characterized based on morphological characters and physiological characters. And then the bacteria that we got, we do potential test of the isolate. The potential test that we have done is EAA production, production, and then phytopathogenic fungi inhibition growth, and the last is phosphate solubilization. Now, this is the isolate endophytic bacteria that we got. There were 5 isolates bacteria. They were Na1, Na2, Na3, Na4, and Na5. Almost all of them is bacillus, and one of them, Na2, is known as criteria based on physiological characterization. The physiological characterization that we use is using microbag. And then we also test the bacteria to inhibit pathogenic fungi. The fungi that we use is Fusarium oxysporum and then Aspergillus niger. Based on our test, Na3 and Na4 were known to inhibit the pathogenic fungi. And then we also do IAA production test. From what we have done, it was known that only A3 and Na4 isolate that could produce IAA. Positive result for IAA production is showed by color changing from yellow from the media become to pinkish like this, like Na4. Na4 has AA production 5.096 microgram per milli, and then Na3 0.6 microgram per milli. And the last, for phosphate solubilization, there is one could solubilize phosphate, which is Na3 isolate. Based on our research, we can conclude that there were 5 isolates of endophytic bacteria that were isolated from the roots of Elephantophus caber, namely isolate Na1, Na2, Na3, Na4, and Na5. There are isolate bacteria that may be able to dissolve phosphate, namely Na3 isolate. There were endophytic bacteria isolated from the roots of Elephantophus caber L that can produce IAA, namely Na3 and Na4 isolates. And the last is there are endophytic bacteria isolate from the roots of Elephantophus caber that can inhibit the growth of phytopathogenic fungi, namely Na3 and Na4. Okay, that's all from me. Thank you for your attention.
Thank you very much for your presentation, Ms. Ana Maria Tulkitia. So it's time for question and answer section. So I have a look in chat box, have several questions. So for the first question is from Ms. Isnawati or Ms. Nurdayatul Alami. Mrs. Nawati asks you about explain about the method that you use for test antifungal activity for fungi and also for plant pathogenic mold. Maybe you can address for this question, Ms. Nurhidayatul Alam. Time is yours.
Okay, thank you so much, Bu Isnawati from Universitas Negeri Surabaya. So I try to answer the questions, Bu. So I think the simple method, I think we use the potato sticks rose agar to grow both the pathogenic fungi and then the yeast. And maybe I can give the more detail about the technique. Maybe for the first, we can inoculate the fungi to the agar, and then it incubate about 24 hours. And then after that, we can inoculate the yeast with a distance around 3 centimeter. And after that, we can incubate about 5 until 7 days. And then we can measure the clear zone around the not clear zone. I mean the changes of the changing of the colony diameter of the fungal from the point of the inoculation until the edge of the colony, and then we can, and then after that we just can get the value of the inhibition. I hope
Yeah.
that clear enough. Who is not
Yes,
Mawati?
yes, thank you.
Okay.
So I think Ms. Nurhayatul Alami still have one left question. Is from Miss Fatima. She asks you about do you using tryptophan as your precursor in production EIA, and then what is pathway this to produce the EIA have to be present tryptophan in that media? Maybe you can address about her question. Thank you very much.
Okay, thank you so much, Bu Fatima from UNER, for the good questions. Yes, that's right, Bu Fatima. About yes, we use the tryptophan as a primary precursor also in this study because, as mentioned, based on many of the study that yes, this IAA biosynthesis is really depend on the supply of the tryptophan. That naturally, this tryptophan can also uh, can can supply from the exudate of the root. So we use this tryptophan with the concentrations about 100 ppm. Thank you so much.
Thank you very much. Maybe I interest with your title, Miss Nurdayatul Almi. I have as one
Yes.
question. Uh, for antifungal production, what I mean, what the fungal type that you use for
Uh,
antifungal? That
yes.
is my question.
Okay, thank you so much, Pak Rico. Actually, we have not investigated the specific kind of the antifungal compound. Yeah, maybe it will be our next research about this. So maybe we can just can assume that this uh, secondary metabolites maybe can coming from the IAA and then others kind of the compound like yeah, hydrolytic enzyme or something like that.
Okay, thank you very
Thank
much
you.
for your answer, Miss Hidayatul Alami. So for next
You're
one
welcome.
is have a question from Miss Isnawati for Miss Mariatul about the kind of metabolic secondary of tapak liman that can inhibit phytopathogenic fungi. Maybe Miss Anna, you can answer this question. Miss Anna Mariatul.
Okay, okay,
Yes.
thank you for the question. Based on what I have read before, the metabolic secondary of tapak liman that can inhibit phytogenic fungi such as flavonoid and tannin, and then alkaloid. Okay,
Okay,
that's all.
very good.
Thank you.
Okay,
Yes,
thank you very much. So I would like to have question for Miss Anna Mariatul. It's quite interesting. So when you exploration bacteria from the root is kind of like something like what is it like the bacteria only can make it for the inhibit pathogenic fungi, or they have another function, I mean from the bacteria that you isolate from root, something like that.
Okay, from my research, the bacteria that we have isolate besides they can inhibit phytopathogenic fungi, they also can produce AAA and then phosphate solubilization.
Okay, something like that. Okay, if thank you very much for your answer. Okay, so for the next, I would like to invite again Muhammad Azri, Mr. Muhammad Azri, that that he present in this section. Mr. Muhammad Azri and Miss Wipa Home Hao from Nareswan University. I invite her deliver her presentation. If I think the both of them didn't present in this season, so maybe this season this is the last of this session. So I would like to thanks to all presenter today, and I would like to remind all of you tomorrow we still have a keynote speaker, and then such all the parallel session also. So I would like to remind you to join us again tomorrow morning. Thank you very much for your attention. Um, See you and bye bye.